Hello and welcome one and all. Today we will cover the k-nearest neighbors, a supervised machine learning algorithm. The k-nearest neighbor, or KNN as it is usually referred to, is an easy-to-implement machine learning model, and yet it can perform quite complex classification tasks. KNN sometimes referred to as lazy learning algorithm, since it doesn't have a specialized training phase and it uses all the training data while classifying a new data point. KNN algorithm assumes that the similar things exist in close proximity. In other words, similar things are near to each other. KNN determines the distance with a straight line between two data points. This is referred to as Euclidean method to determine the distance. Let's see this algorithm in action with the help of a simple example. Let's assume that we have two categories of data, red and blue. This is our training data set. Then we receive a new data point, x, and we want to classify the x data point to red or blue category with the help of KNN. KNN requires the value of k, which we set to 3. The KNN algorithm starts by calculating the distance of point x from all data points. Then it finds the nearest 3 data points with the least distance to x. The 3 nearest data points have been circled. It chooses 3 data points because we set the value of k to 3. If we were to set the value of k to 5, then we would have chosen the nearest 5 data points. We have 2 blue data points and 1 red. KNN will assign the x to the class to which most of the k data points belong to. So in this case, x belongs to blue category. Let's implement the KNN algorithm with Scikit-Learn in Python. Dataset and Jupyter Notebook are available on GitHub. Link is in the description below. I have my Jupyter Notebook open, and as usual, we will begin with importing the required libraries. Make sure you have these libraries installed prior to running the code. We are using the social network ad dataset from Kaggle. The dataset contains the detail of users on a social network site. We want to find out whether a user buys a product after clicking the ad on the site. This dataset captures user details such as user ID, salary, age, gender, and whether or not user made the purchase. I will import the dataset into a data frame with pandas library. Let's display the first 5 rows of data frame to get a sense of the data. We can find out the number of rows and columns with the shape function. We have 400 rows or observation and 5 features or columns in our data set. You can do further analysis on this data using Exploratory Data Analysis, but I'll leave that up to you. I have a video on Exploratory Data Analysis. I'll leave the link to the video in the description below. Our data set contains gender column, that is categorical variable with labels of male and female. We will need to convert this to numeric, for example 0 and 1. I am encoding it using pandas getDummies function. You can also use Label Encoder from Scikit-Learn. If you need an example, I have covered this in my previous video on multiple regression. I will leave the link in the description below in case you want to check it out. The next step is to split our dataset into labels and target variable. We will save the labels in X variable. For X, we will drop the user ID and purchased column, so the X only has the labels. We will set the Y to purchased, the target variable we want to classify. Let's split the dataset into train and test datasets. We will use the train, test, and split from Scikit-Learn. We are providing the test size as 30%. That means our training sample contains 280 records and test sample contains 120 records out of 400. We can go ahead and create our model now. I'll create an instance of the k-neighbors classifier and we will set the n-neighbors value to 4. The metric to Minkowski. Minkowski is a distance or similarity of measures between 2 points. and we will set the p-value to 2. P-value of 2 means that we are setting the measure of distance to Euclidean distance. Once we execute this cell, our model is created. We will train the model with trained datasets. We will call the fit function from KNN and supply it with X and Y trained dataset. Let's check the score of our model with the score function. The score function takes X and Y test datasets. Model test score is 81 out of 100. It is pretty good, but certainly can be improved. We could use this model to predict the output for the test dataset. I'll select a row from the test dataset with an index of 2. I'll pass this to the knn.predict function, and it classifies this row as a purchase, meaning this user made a purchase. I looked up this index in the original dataset, and indeed, the purchase column is equal to 1. So our model predicted this correctly. Let's try and get the optimal value of k for this dataset. This may increase the accuracy of our prediction once we update the value of k. I'll go ahead and create 2 empty lists to store all the different scores for the values of k. I'll call the model in a for loop and set the values from 1 to 40. In the loop, I am calling the model and appending the scores for test and trained dataset to the list I have defined above. Let's go ahead and plot the above scores to check at what k value we have optimal score for our model. It seems if we set the k value to 5 for trained dataset, we'll get higher accuracy. Just an FYI, we don't want to set the k value to too low or too high. This may cause overfitting. For evaluating the model, confusion matrix and classification report are the most commonly used metrics. Confusion matrix requires y-test and y-predicted dataset. We will predict the values for x-test dataset and save the outcome to y_predict variable. We will pass the y-test and y-predict to the confusion matrix. It gives the outcome in an array. For better understanding, we will plot the confusion matrix in a heat map. We have 120 records in the test dataset, 83 records where user did not make a purchase, and 37 records where a purchase was made. Out of 83, the model correctly classifies 76 records, and 7 records were misclassified. Also, 15 records were misclassified where a purchase was made, but model classifies this as no purchase. Let's go ahead and print the classification report for our model. The results show that our KNN algorithm was able to classify all 120 records in our test dataset with 82% accuracy, which is very good. Classification report gives us a breakdown of each class, 0 and 1, and how accurate our model was across these classes. If you want to learn more about classification report, I'll leave a link in the description below that covers it in details. To see if the optimal value of k has any impact on the accuracy of prediction, we will update the model with the k value of 5. Let's train the model with the updated value and run the score function again. This is to test if the optimal value gives us any improvement. We can see an improvement in the score. In order to improve this model further, we can scale the features and run through the cycle again to see if there is any further improvement in the score. But I'll stop here, and in the next session, we will create a recommender system using KNN. I hope you find this session useful. If you like the content, be sure to like and subscribe. Post any questions that you may have. Take care of yourself, and I'll see you in the next video.